We have all looked at a standard multiplication problem, like 116 times 5, and felt the urge to reach for a calculator. Stacking those rows on paper is slow and often creates more room for error. There is a faster way. Multiplying any number by 5 is the mathematical equivalent of dividing that number by 2 and then multiplying the result by 10. Applying this to 116, we divide the number in half to get 58. Multiplying by 10 simply means adding a 0, so our answer becomes 580. A similar logic applies to larger multipliers. Multiplying a number by 25 is the same as dividing that number by 4 and then multiplying by 100. For 824 times 25, we divide 824 by 4 to get 206. Adding two zeros to multiply by 100 gives us a final answer of 20,600. Using these fractions as shortcuts allows us to handle large multipliers through mental math rather than long-form arithmetic. Beyond calculation, we can also predict how many digits a product will have before we even start the math. For example, the product of any two two-digit numbers will always be exactly 3 or 4 digits long. The smallest two-digit numbers, 10 times 10 equals 100, establishing our 3-digit minimum. For the limit, the smallest three-digit numbers, 100 times 100 equals 10,000. Since this is the smallest 5-digit product, factors under 100 must yield answers under 10,000. This pattern scales up. Multiplying two 3-digit numbers will always result in a product that is either 5 or 6 digits long. These boundaries provide a way to check the accuracy of our results and understand the limits of large numbers. These numbers describe the physical world around us. We can start with a baseline measurement of 1 meter, roughly the height of a young student. A single floor in a residential building is about 4 times that height, or 4 meters tall. Now consider the Statue of Unity in Gujarat. It stands 180 meters tall. To put that in perspective, this statue is roughly the height of 4 of those apartment buildings stacked on top of one another. Comparing these heights helps us use simple multipliers to visualize the scale of massive structures. Natural formations reach even greater heights. The Kunchikal Waterfall in Karnataka has a total drop of 450 meters. To understand that distance, we can calculate how many residential floors it would take to reach the top. By dividing the 450-meter height of the falls by the 4-meter height of a single floor, we find it would take a building 112 stories tall to match the waterfall. These calculations allow us to map and compare the extremes of the physical landscape. Now we can apply these exact same tools to the immense distance between the Earth and the Sun. By multiplying 2100 by 70,000, we find the total distance, 147 million kilometers. Large numbers also hide at the microscopic level, like inside a single gram of healthy soil. That single gram of dirt can contain between 100 million and 1 billion individual bacteria. Within that same gram, there are also between 1 lakh and 1 million microscopic fungi that support plant growth. Whether measuring distances to stars or organisms in a handful of soil, large numbers provide the scale for our universe. You now have the tools to navigate these scales, from predicting product lengths to division shortcuts. Here is a final test. Try to mentally calculate 240 multiplied by 25. Use the shortcut from earlier. Divide 240 by 4 and then add your zeros. Once you have the answer, share it in the comments below. Using these mathematical techniques makes it possible to process large numbers quickly and accurately.